Okay, so now we're going to have a look at group data sets, finding the median. Now this is basically an estimation of the median, but it's a pretty good approximation of the median. So we have a formula that goes with, but first I need to show you how we set the table out. So the table is slightly different. Because it's groups, then our score column is no longer our X. Our score column is our grouped intervals. So this one is 0 to less than 10, 10 to less than 20, 20 to less than 30, and 30 to less than 40. It is important that you don't have intervals that overlap. So you can't have 0 to 10, 10 to 20, because then basically where would 10 go? Does 10 go in this one or does 10 go into this one? So this is everything from 0 up to 9.999999, and then everything from 10 up to 19.99999. And on. We have our frequency column, still an F. We still have our FX and CF. However, our X, instead of having our grouping, our X is now our midpoint. Now to find the midpoint, what we do is we add our upper and lower boundaries. So that would be our lower boundary of 0 and our upper boundary of 10, and then we divide them by 2. That gives us 5. Over here, 10 and 20, so lower is 10, 20 is upper, that gives us 30. Divide that by 2, 15. Okay, 20 and 30 and so forth. So we get 25 and 35. So if we add 30 and 40 and divide it by 2, we get 35. So it is important that you actually do that and don't just guess the middle, because you could be out as you go along. Next, our FX. So this is these two multiplied together. So 2 times 5. And then we have 5 times 15. Then we have 9 lots of 25. So all getting lost out of room. 225. And 8 lots of 35 gives us 280. Okay, and again, we're going to add these because we like our sum of. So this is our total sum of FX column, and that's going to be 590. So what's really important to remember is the reason that we do the midpoint and why I say that we're estimating the median. When we have a grouping, we don't actually know which scores, what individual scores belong in that group. So it says right now that there are two data points within 0 to 10. Now that could be 0 and 1. That could be 1 and 1. It could be 9 and 9.5. It could be 1 and 7. We don't actually really know. And so when we have group data sets, we have to estimate the mean and the median and the mode. We're basically just, it's an educated guess, but we are still guessing. So what we're doing is we're assuming that the data spread within each group, if it is optimal, so if it's symmetrical distribution, it's going to be around the center that we can use as our midpoint. We're assuming there'll be some below 5, some above 5, some of the 5 will be below 15, some above, both ways. So it gives us an approximation. Now what we do then is we use this formula. Now don't freak out when you see the formula. It is quite large, but each thing stands for something different, and as long as you know what it stands for, it's easy to use. So the median, L plus, and we put our big brackets in, N over 2 minus CF of B divided by frequency midpoint times the width. Okay, so here's what each of them mean, and that's important to remember. Easy. Okay, L, lower class boundary. Okay, so remember when I said 0 to 10, so 0 is the lower class, it's the lower end of that interval. 10 would be the lower class boundary. Here, 20 would be the lower class boundary. And just like before, total number of data. Then we have CF with a little b. Now that is the cumulative frequency of the groups before the median group. Okay, so the little b just stands for cumulative frequency before the median groups. And then our F with a little m is frequency of median group. And W is the width. Now the width of the group is basically those what the intervals go up in. So 0 to 10, 10 to 20, 20 to 30, there are lots of 10. Okay, so if I just go upper minus lower, so 10 minus 0, 10, 20 minus 10, 10, 30 minus 20, 10, 40 minus 30, 10. Every time. So to find the width, you just go upper boundary minus lower boundary. Okay, and that will give you the width. Okay, so what we're going to do is, just like before, the first thing we do is we find median position. We use the same formula, n plus 1 over 2. Our total number of data is 24. Sorry, I just moved the table. Don't lean on the table. Okay. 24 plus 1 over 2. So that's going to be 25 divided by 2, which is going to be the 12 and a half data. Now, how do I know? Well, we fill in our cumulative frequency column. So we should have actually done this already. Okay, so frequency started at 2. Then we added on 5. Oh, sorry. Let me try doing it in different colours so it stands out a bit more. 2. Then 5 plus 2, 7. 7 plus 9, 16. And then 16 plus 8. Matching. Beautiful. Okay, so now that we know our cumulative frequency, our 12 and a half data, so 2, no, 7, no, 16. We've gone past 12 and a half. So after the 7, but before the 16. So it's this group here. So I'm just going to circle this. This is our median group. So once we find our median position, we know what our median group is, then we can use this formula here. Okay, so I'm going to do it just down the bottom here. And I might be able to just pull it up a little so that there's enough for you to be able to see. Okay, so what I'll do is write the formula. So L plus n over 2 minus our CF little b, all of that over the frequency of the median group, multiplied by the width. Put that all in brackets. Okay, so now I'm just going to sub in. Okay, so that's my K1. Beautiful. Now for K2, I'm going to sub in what I know. So L is my lower class boundary. So my lower class boundary in my median group and I'll put that in so that you remember, in the median group is 20. So that's going to be 20 plus, so N is number 24 over 2 minus cumulative frequency before the median group. This is the median group. So the cumulative frequency of all the groups before it is 7. So that becomes 7 over frequency of the median group. So this is it here, median group, 9. And multiplied by the width. Now remember I said width is upper minus lower. And so 30 minus 20, 10. 40 minus 30, 10. So 10. 10 is the width of my groups. And they should always be the same. Then basically I'm going to put all that into the calculator. So if your calculator is a little bit funny, you might have to do each bit at a time. So 24 divided by 2 equals minus 7 equals divided by 9 equals times 10 equals plus 20 equals 25.5555 and so forth. So what we end up with is 26, and we're just going to do that to 0 decimal places. So remembering that, okay, I've got my formula K1, but I also get K2 for showing that sub in. I get K3 for showing that I can calculate, C1 because I rounded properly. You know, over here I've got my C2 for organisation, C3 and C4. Okay. Even over here, K1, K2, K2 again, and K3 where I've calculated. Okay, I've actually applied this law properly. Now, as you can see, I understand that when you look at this rule, you think, oh my God, it's so huge. But all you have to remember are these letters. And once you've done a few of them, you start remembering, oh, L, lower class, M, median group. We already know CF, we know F, we know N, yeah, L, W, and these little M and B are the only things. So L is lower class, W is the width of the group, your interval. The little m just means of the median group, and the little b means before the median group. So make sure you have a practice of questions using estimating the median from grouped data sets.